Okay, we have here today another interesting integral from Swinbee 2018. This was problem 8. We have the integral of natural log 1 plus x over 1 minus x dx. And you may notice this is a problem I already did. I just wanted to do this using an alternative method that was just in the comments by Busto2915. And his method for doing this was converting it to hyperbolic inverse tan. Just look at that identity right now. So we have this formula over here to the right. What we can do is use this to convert our integral from natural log into this hyperbolic inverse tan. But just to get it ready to use, what we just need to do is multiply by 2 on both sides, multiply by 2 here. So then now this is exactly what we have in the integral. So what we can do is rewrite our integral using this. So we'll just write this 2 tangent inverse x dx. And then for this, what I'll do is we'll just use integration by parts on this. So I'll do tabular integration, DI method. And so what I'll do is, I don't really know how to integrate this, so I'll differentiate tangent inverse x. But then what I can do is just integrate 2. So doing that, the integral of 2, that's just going to give me 2x. Now the derivative of inverse tangent is just going to be 1 over 1 minus x squared, just remembering the formula for that. Then so we'll take part of the solution right here on the diagonal, so I'll write that part down. 2x tangent inverse x. Then here we'll have an integral, and I think what I'm going to do, I'm actually going to write it as plus, and then I'll combine minus 2x in the numerator, and then we'll write this part 1 minus x squared dx. But now for this thing, we can definitely do a u substitution. What I'll do is, I'll just call this part my u. So we'll say u equals 1 minus x squared. So I'll just take a derivative, and so we'll have du equals, derivative of this is going to be minus 2x dx. That's exactly what we have right here in the numerator. So I think what I'll do is just take this integral off to the side here, and we'll make the substitution. So this is just going to become du over u. But integrating that, we know that's going to be natural log absolute value of u. We'll back substitute here with our u value, right? So then we'll finish this. We'll have to come back and put it all together, but for this part, we're just gonna have natural log absolute value 1 minus x squared. So now let me just take this and we'll plug this back in here and see what we have left. Okay, now to finish it off, I could actually just put a plus c and circle it, but what I wanted to do is get it back into the form that we had it in the previous video, and for that, what I need to do is just use the formula again for the inverse tangent. So for this, unfortunately, I erased it from the board, but this thing, once again, was 1/2 natural log 1 plus x, 1 minus x. So to finish this off, we'll just distribute in this 2 to the 1/2, and that's going to cancel. And so for my final solution, we're just going to have x natural log 1 plus x, 1 minus x, plus natural log absolute value 1 minus x squared. Now put a plus c, and that's it. Okay, so there you have it. Interesting alternative method from the comments. Thanks everyone for watching today. Have a great day.